Preparing data for machine learning. It is a crucial step in the process, as the quality and format of the data will greatly affect the performance of the model. Here are some best practices for preparing data for machine learning. Understand the data. Before starting to work with the data, it is important to understand the data and the problem you are trying to solve. Understand the meaning of the variables, the data types, and the distribution of the data. Clean and pre-process the data. Data cleaning and pre-processing is an essential step in preparing data for machine learning. This includes removing missing or duplicate data, handling outliers, and correcting errors. It's also important to make sure that data is in a consistent format and that categorical variables are properly encoded. Split the data. It's a best practice to split the data into training and testing sets. The training set is used to train the model, while the testing set is used to evaluate the performance of the model. A good rule of thumb is to use 80% of the data for training and 20% for testing. Scale the data. Most machine learning algorithms require that the data is scaled, which means that the data is transformed so that it has a mean of 0 and a standard deviation of 1. Scaling the data can help to improve the performance of the model. Feature engineering. Feature engineering is the process of creating new features from the existing data that can improve the performance of the model. This can include creating new variables, transforming variables, or combining variables. Handling imbalanced data. In some cases, the data may be imbalanced, meaning that one class or category has significantly more instances than another. This can lead to a model that is biased towards the majority class. To handle imbalanced data, you can oversample the minority class, undersample the majority class, or use a combination of both. Keeping track of data. It's important to keep track of all the data pre-processing and cleaning steps that you have performed on the data. This will allow you to reproduce the same pre-processing steps on new data in the future and also to understand how the data has been transformed, in case if you need to go back and adjust some steps. Regularize the data. Regularization is a technique used to prevent overfitting by adding a penalty term to the cost function. Regularization shrinks the coefficients of the model and can help to improve the generalization performance of the model. Use cross-validation. Cross-validation is a technique used to evaluate the performance of a model by training it on different subsets of the data and averaging the results. This can help to reduce the variance in the model performance and provide a more accurate estimate of how the model will perform on new data. By following these best practices, you can ensure that the data is in the best possible format for machine learning and that the model will be able to perform well on new data. Thank you.